Hello everyone. In this video tutorial, we will see how we can do object tracking using YOLO-NAS. For object tracking, I will use SORT algorithm. We will see how we can track the detected objects using YOLO-NAS and SORT algorithm. In this YOLO-NAS with object tracking course, we will start from very basic. We will see how we can read an image and video, and we will also see how we can do object detection on images and videos. Then we will go further and see how we can track each of the detected object using YOLO-NAS and SORT algorithm. And we will also be implementing a project in which we will count the vehicles entering and leaving using YOLO-NAS and SORT algorithm. So let's get started. If you want to implement your computer vision ideas to solve real-world problems, then do check out these two courses, YOLO V8, Object Detection, Tracking, and Web App in Python 2023. This course was launched last month on Udemy, and it has currently 199 students enrolled and 4.4 ratings. And it contains about 12 hours on-demand video with 64 downloadable resources. And here is the course content or what you will learn from this course. And you can see over here, you will learn web app development with Python, and you will learn object detection, tracking, object segmentation, and tracking. So this is a complete course. Here you can see that our overview of different object detection algorithm is also presented, and the numbers speak itself. And here's another course. This is the bestseller course on Udemy, and the course is YOLO V7, YOLO V8, and YOLO VNAS. In this course, 3 object detection algorithms are being covered, which include YOLO V7, YOLO V8, and YOLO VNAS with object detection, tracking, and web app. So here, what you will learn in this course, you will learn object detection, tracking, pose estimation, and web app development in Python, how you can integrate your object detection algorithm with a web app you will learn, and how you can also integrate different object tracking algorithm with the object detection algorithm, and how you can track each of the detected object using a deep sort algorithm, byte track. So this course contains around 19 hours on-demand video tutorials with 85 downloadable resources, and the course has 4.7 rating, and this course is also launched last month with 77 students, and this is the best seller course on Udemy. So the link of both of these courses are given in the description box, and if you just click on the link, you will get 35% off, and this course will be available in $13, and this course will also be available in $13. And if you just click on the link in the description, you will also get 35% off. So the link is provided in the description. Do check out these courses. In the first part, we will see how we can read an image using OpenCV. So here you can see that I have created a folder by the name YOLO-NAS Object Tracking PyCharm. So here I have created an empty folder. You can create this empty folder in any of your directory. So now I will just open PyCharm. So here I have opened the PyCharm. So I will just go to File and then click on New Project from here. And now I will just select the directory which I have created for this project. Okay, so I will just go to YOLO-NAS course, and here I will just select YOLO-NAS Object Tracking PyCharm. So this is the folder which I have created for this project, and my base interpreter is being set as Python 3.10. So that's fine as well. So now I will create a new project by just clicking over here and clicking on this window. Okay, so I'm just creating a new project now. So now it's creating a virtual environment, and so this might take few seconds. So let's wait until we have everything ready. Okay. So as I told you, in the first part, we will see how we can read an image using OpenCV. So this will be focused in our first part. So it's creating a virtual environment. So this might take few more seconds. Okay. So now it's updating the Python interpreter. So now along with this, you can see over here, we have created a project over here, and here is our main.py file. Okay, so if I just run the Python main.py file, it will just print the PyCharm. So let me just run this. Okay, so let me just get it ready. Okay, just write Python main.py. Okay, just write Python main.py and okay. So now just run this. Let's first run this out and see whether we are able to print PyCharm or not. So now you can see that we have printed high PyCharm. So basically here we have the high and here we have the PyCharm. So that's working fine. So now to read an image using OpenCV, we require only one library, which is OpenCV Python. To install this library, there are two ways. Let me just first discuss the first way. So you can just click on File, and then you can just go to Settings from here. And then you can click on the project from here and then select the Python interpreter from here. And then just click over here, plus. And here you can write over here OpenCV Python. Okay, so if I just write OpenCV Python over here, so now you can see the OpenCV Python package over here. So now you can just click on install package from here and this package will get installed. So this is basically the first way of installing OpenCV Python package. So currently you can see that installing package OpenCV Python. So it means that OpenCV Python package is getting installed. Okay, so that's fine as well. Okay. So the next thing we can do is just close this out from now. Um, so these are the three packages which are already installed, and now we are installing OpenCV Python package, and you can see that our Python interpreter is being set at 3.10. Okay, so now you can see that OpenCV Python package is installed successfully, and now you can see that NumPy comes with the OpenCV Python package, and we have installed the OpenCV Python package, and its version is 4.7.0.72, and our NumPy version is 1.24. Okay. So this is the one way you can install the package, and other ways you can just click over here and just click on file and create a requirements.txt file. Okay, so now you can see over here, I have created a requirements.txt file. In the requirements.txt file, you can list all the packages which you require. So I will just write opencv-python as I only want the OpenCV Python package. So to read an image, I just want the OpenCV Python package. So in the requirements.txt file, I have written OpenCV Python package because it is already installed. So you can't, you will not see over here install the OpenCV Python package. But if some package is not already installed, you can see over here the alert like, please install this package OpenCV Python. But you can install the packages by just writing pip install -r requirements.txt. In this way, you can install the packages which you want to install. Okay. So now I'm just installing the OpenCV Python package now. So this might take a few more seconds. So currently OpenCV Python package, because I've already installed the OpenCV Python package. So you can see that requirements already satisfied OpenCV Python and NumPy, because I've told you that we have installed the OpenCV Python package. So now in the next step, so if you have some other packages as well, you can just write the name of those packages over here and you can install those packages as well. So now I will just click over here and just create a directory, new directory. So in the first part, I told you that we will see how we can read an image using OpenCV. So I will write lecture 1, read image OpenCV. So in the first lecture, we are just seeing how we can read an image using OpenCV. And inside this, I will just create a folder. I will just create a .py file. Okay, read image OpenCV.py. Okay, so I have created a .py file inside this lecture 1. So here I will just write the code how we can read an image using OpenCV. But what we are reading, we need to read an image. So we should have an image which we want to read. So I will just click over here and create a new directory and image. And inside this image directory, I will add some images. So let me add some images into this image directory. So now you can see over here, we have created a directory by the name image. And inside this image directory, you can see that I have added these 4 images now. Okay, so these are the 4 images which I have added inside the image directory. And here is our image directory, which I have created in the PyCharm. So let's go back towards the PyCharm code. So now here you can see our PyCharm.py file over here. And here if you just see the image directory, you can see the 4 images over here. Okay, so I have told you in the requirements.txt file, we have installed the OpenCV Python package already. So what I will do is, first of all, I will import the OpenCV Python package by CV2. So to import the OpenCV Python package, we write import CV2. So I will write import CV2 over here. Then I just want to read the image using OpenCV Python CV2 package. So I will write image is equal to cv2.im read, and where we have the image. So I just need to go back towards this directory lecture1, and then I just need to go towards the image directory and then read the image. So what I will do is, first I will go outside this directory, and then I just need to go to the image directory, and then I just need to read the image.jpg. Okay, so now I'm just reading the image. So now using cv2.im read, I am just reading the image, this image. So now let me display this image. So I will just write cv2.im show. Okay, so just write over here cv2.im show, and here I will just write the name of the frame as image, and here I will just write image, and now I will just write cv2.wait key 0. So now I'm just reading the image using OpenCV. So let me just run this. So first of all, I just need to go to this directory, just copy path, reference, absolute path, and just write cd, and then click on enter. And I have to write python read image dash opencv.py. So now I'm just inside this directory, lecture1 read image OpenCV, and I'm reading this image using OpenCV. So I will just click on enter. So I'm just reading this image.jpg using OpenCV Python. So now you can see here, let me just show you. So now if you just see over here, our output image is not being fit into the screen. Like we are not able to fit the output image into our screen. So how we can just fit our output image into our screen? So what we can do over here, we will use the cv2.resize function for this. So fit the output image into our screen, we will use the cv2.resize function. So I will write resize dash image cv2.resize. So I will be using cv2.resize function. Okay. And here I'm just writing image. Then I will just define the coordinates point over here. Now I will define the scaling factor over here. Fx is equal to 0.2. Okay. Fy is equal to 0.2. Next, what we need to define is, next we will define the interpolation. So I will write interpolation is equal to cv2 dot inter dash area. Then just correct. Okay, so I have resized the image using OpenCV. I'm just scaling the image by so I'm just shrinking the image to 20%. The size, I'm just shrinking the size of the image to 20%. So now here I will write resize dash image, and let me just show you how our output now looks like. So now we have just resized the image or shrink the image to now to 20% of the original size, 20% of the original size. So now let me just run this. So now here you can see that we have, let me just show you the output image. So now you can see over here, so So now you can see over here, this is the output image, and the output image is now fit into the screen. And we can see over here, these are the two persons working on a solar project, and that's worked perfectly. We are able to read and display the image using OpenCV. So in the first part, we have seen that how we can read and display the image using OpenCV Python. In the second part, we will see how we can read a video and display the video using OpenCV Python. Read and display the video using OpenCV Python. We will cover this in the next part. In the first part, we have seen that how we can read and display an image using OpenCV Python. Now in the second part, we will see how we can read and display the video using OpenCV Python. So we will read and display the video using OpenCV Python. So first of all, I will just create a new directory. So this will be read lecture 2, read, display, video, OpenCV. So now we are just reading and displaying the video using OpenCV Python. So this is the other directory which I've created, and inside this directory, I will just create a .py file. So this lecture will be in the to consist of two parts. So I will just write part1.py, and for the second part, I will just create part2.py file. Okay. So as now we just want to read and display the video using OpenCV Python. So we just need to have a video, some videos as well, which we are just want to read and display. So I will just click over here and create a new directory over here by the name video. So here I have created a directory video and click on enter. So now in this directory, I will add some videos. So let me just go back towards the folder. So now you can see over here, we have the video directory. So let me just add some videos into this directory. Currently this video folder is empty. Now you can see that I have added plenty of videos into this video folder, which you can see here. I've added 6 different videos into this video folder. So let's just go back towards the code and let us read and display the video using OpenCV Python. So I will write import cv2 cap is equal to read the video, I will use cv2.video capture function. And currently I am in this folder, lecture 2, read and display video OpenCV. I will just go back towards from this folder and just go towards the video folder and just read any of the video from here. So I will just write over here dash video. So I'm just going back to the, I'm just going outside the folder over here and just write video. I'm just going towards the video folder and just write here bikes.mp4. Okay. I'll just remove the space from here. We don't need this. Now I will just write over here stream is equal to cap dot read. Okay. So if you just want, you can just write rect from a frame cap dot read cv2 dot im show frame, and just write over here cv2 dot wait key 0. So it will just read the first frame of the video. So first of all, I will just click over here, click on copy path reference and just copy the absolute path from here. Just write this and just write Python part1.py. So now we will, so now you can see over here, we are, okay, so let me just navigate my screen over here. So now you can see over here, we are able to read only the first frame of the video using OpenCV Python. But if you just want to read and display the complete video. So what we will do is we will create a while loop and we will read each of the frame one by one and we will display a complete video. Okay. So I will just go back from here to the code. So now what I will do over here is I will just create another file by the name part2.py. And then over here, I will just write the complete code, how we can read and display the video using OpenCV Python. So I will write over here import CV2. And then what I will write over here is gap is equal to CV2 dot video. So to read the video, I will just use video capture function dot video capture. So currently I am in this folder. I will just go outside this folder and go into the video folder and then I will read any of the video from here. I'm just going towards the video folder and I'm read pikes.mp4. Okay. So I have imported the CV2 library. I have used the video capture function to read the video. But if in any case, for example, if our video path is not correct or if the video file format is not supported, so we can do it right over here. Cap dot is opened is equal to false. Then I will just play the print message print unable to read for the video. Okay. So if in any case we are unable to read the video, either the file path is not correct or it's not supported, like file format is not supported. Okay, so I will just display this message. But if we are able to read the video, I will just write while cap dot is opened. Then I will write read comma frame is equal to cap dot read. And I will also write if read cv2 dot im show frame. So this is the name of the frame. I just want to write cv2 dot im show frame. And then I will just write over here if cv2 dot wait key 1 and 0 fx is equal to or is equal to 1, then I will just, so if I just press the 1 key, then the video will stop or break from there. Okay, so just correct this out from here. It will break. Okay, so if I just press the, if we are displaying the video and if I just press the 1 key, the video will break from there. Okay, else I will write break from here. Then I will just write cap dot release cv2 dot destroy all windows. Okay, so now here you can see over here I have written the code so that we can read and display the video using OpenCV Python. Okay, so let me just run this from here. And let's see whether we are able to read and display the video using OpenCV. So now you can see over here, we are able to read and display the video using OpenCV. So we have seen that how we can read and display the video using OpenCV Python. Let me just add another video name over here and let's see how we can read and display the video using OpenCV Python. So I will just write video1.mp4 and let's run this and let's see on this video. So now you can see over here, we are able to display the video, but the video is not able to fit on the screen. So I will just press the 1 key so that you can see the video is now stopped or it's break at that time. So I will just write over here resize frame, cv2 dot resize, and here I will write frame and the coordinates over here, and then I will just scale it by 50%, and plus I will just write interpolation is equal to cv2 dot inter dash area. Okay, so just copy this from here and like add this. So let's read and display this video again. So now I've just scaled this video 50%, so now that it can be displayed on the screen. Okay, so just run this now. So now you can see over here, we have just scaled the video 50%, and now you can see that we can clearly see the output video over here. We have just resized the frame using OpenCV Python cv2.resize. And this way you can display other videos over here as well, like demo. And let's run this. Okay, so now you can see that the video is not able to fit the screen. So now we will just take 20% of the video, so 20% of the original frame. Okay, so just write 0.2 over here and just click on enter from here. So now we are just taking 20% of the original frame, and you can see over here we are able to display the video using OpenCV Python, and here is the output video. Okay, so that's working quite fine. Okay, so I will just press 1 and break this. Okay, so now here we have seen that how we can read and display the video using OpenCV Python. In the next lecture, we will see that how we can save the video, or you can say that how we can save the output video. So using OpenCV Python. So we have read and display the video. So what the video which I have displayed, how I can save that video using OpenCV Python. So this we will cover in the next part. In the last lecture, we have seen that how we can read and display the video using OpenCV Python. In this lecture, we will see how we can read, display, and save the video using OpenCV Python. So now for this, I will just create another directory over here, and this will be lecture 3. And here I will just write the read, display, and write video OpenCV. So in this video tutorial, we will see how we can read, display, and save the video using OpenCV Python. So now I will just create a .py file by the name over here, read, display, write.py. Okay, so I will just go to the part2.py file and just copy this code from here and just add this code over here. Okay, so to save the video, I will use the cv2.videowriter function. So first of all, I will just write over here frame-width int cap.get3, and then I will just write frame-height, and I will write int cap.get4. Then I will just use the cv2.videowriter function. So I will write out is equal to cv2.videowriter. And here I will just write the name of the output by which we want to the name by which I want to save the output video. So I will write output.avi over here, and I will write cv2.videowriter dash 4cc. Okay, so just let me just correct cv2.videowriter dash 4cc. I think this is capital cv2.videowriter dash 4cc, and I will write over here mj p. So this is the format I just want to save the output video. MJPG over here. And here I will just write the frame rate, and here I will just write frame dash width, frame dash height. Okay. So by this name, I just want to save the output video. I've written over here, and what I will just write over here is just press enter from here. Okay. I will write out dot write, and here I will just write frame over here. Okay, and here I will just write out dot release. So let's run this and see whether we are able to save the output video or not. Okay, so just first of all, before running this, just click on over here and just click on copy path, copy the absolute path, and just write cd over here, and just write Python read display write.py. Okay, so now we are reading, and okay, so what is no such file? Okay, so read display dash write. Okay, just click on here. So okay, so now I'm in the Gulf directory. Okay, so now run this. I hope it will work fine now. Okay, so now you can see over here, we are able to display the video over here. Okay, so let's see, we are able, either we are able to save this video or not, like save this output video or not. So just press 1 now. And let me just go back towards the folder where I just want to save this video. Scores from here. And here it will be, okay, and here you can see that read display write. And here you can see that here is our output video. Let me just play this output video. So now you can see over here, we are able to read, display, and save the output video. So that's working quite fine. Let me just go back towards the code. So now let me show you how you can capture the videos using live webcam feed. Okay, so I will be using the webcam of my laptop. So in the next part, we will see how we can capture the video using live webcam feed. So we will cover in the next part. Now we will see how we can capture the video from camera using OpenCV Python. Okay, so first of all, I will just go to this directory and create a new directory and just write over here lecture for capture video from camera. Okay, so we will see how we can capture the video from camera using OpenCV Python and how we can save that captured video. So I will just write a .py file capture video camera .py, and I will just copy all this from here and just paste this over here. I will just make one change. I will just remove the video path from here and enter 0. So as I'm just using my internal laptop webcam camera, but if you are using external webcam, so you can just write 1 over here. But as I'm just using internal, my laptop camera, so I will just write 0 over here and just go to CD and set this folder as our grunt directory. Okay, and just click on enter and write Python capture video dash camera .py and then click on enter. Okay, so now it will start. Okay, so now you can see that I have just resized the frame, so it's very small. So I will just update this from here because I have resized the frame, so it's very small. So I will just remove this resized frame or comment this out and just use the original frame from here. Okay, and now let's run this and see how our output looks like. So now you can see that we are able to capture the video from camera. So now let's see whether we are able to save that video uh, or not. So I will just go to the lecture 4, and here you can see that we are able to save the video as well. Okay, so now you can see over here, we are able to capture the video from the live webcam feed, and you can see over here, we are able to save the video as well. So that's what I expect is, so that's all from this part. In the next part, we will see how we can do object detection on the images using on images and on the video using YOLO-NAS. So in the next part, we will see how we can do object detection on images and videos using YOLO-NAS. Now we will see how we can do object detection on images using YOLO-NAS. So let me just close these files. Okay, so I will just click over here and create a new directory. It will be lecture 5 object detection images YOLO-NAS. Okay, so inside this, I will just create a file like object detection YOLO-NAS .py. Okay, so if you want to do object detection on images using YOLO-NAS, we require super gradients package. So I will just write over here super gradients. So to do object detection using YOLO-NAS, we require this super gradients package. So I will just write super dash gradients, and the version will be 3.1.0. Okay, so I will just click on install requirements from here to get this package installed. So now you can see over here, it's installing package Super Gradient 3.1.0. So this might take 5 to 10 minutes for this package to get installed, Super Gradient 3.1.0. So let's see. Now the super gradients package is being installed. So now I will just go to object detection.py file over here. And now I will write the code how to do object detection using YOLO-NAS on images. So first of all, I will import the OpenCV Python library, import CV2. Then as you know that to implement YOLO-NAS object detection, we use super gradients package. So I will write from super gradients import models. Okay, so I think one thing is missing over here from supergradients.training import models. That's fine. Then I will do is model is equal to models dot get. So now YOLO-NAS comes with 3 different models: YOLO-NAS small, YOLO-NAS medium, YOLO-NAS large. So in this complete project, I will be using YOLO-NAS small model for object detection. What is the difference between YOLO-NAS small, medium, and large model? YOLO-NAS small is the fastest among other YOLO-NAS model, but it is less accurate. While YOLO-NAS large is the most accurate among other YOLO-NAS models, but it is less fast. So I will be using YOLO-NAS small model. So I just write YOLO-NAS S. So if you just want to use YOLO-NAS small model, you will write here S. But if you want to use YOLO-NAS medium model, you will write M. And if you just want to use YOLO-NAS large model, you will write L. Okay. So I just want to use YOLO-NAS small model for object detection because YOLO-NAS small model is the fastest, but it is less accurate. So I don't have GPU. I'm just doing object detection on my CPU. Okay, so therefore I'm just using the YOLO-NAS small model because it is fastest as compared to other YOLO-NAS models. Then I will write over here pre-trained weights is equal to Toko. Okay. Then next thing what I will do is So you can also add this device is equal to torch.device. Okay, so if you have a GPU available, you can just write CUDA 0 if torch dot CUDA dot is dash available, and then you can write else torch dot device CPU. Okay, and here we can write dot to device over here. So that's fine. And you can just write over here import torch. Okay, so now we have next thing which we can do is over here is I will write out is equal to model dot predict, and inside over here I will just add the image path. So currently I am inside this folder lecture 5 object detection images OpenCV. So I will just go outside this folder and then I will just go to the image folder and just write image dot jpg. So let's do object detection on this image and just write out dot show. Okay, so just write over here, so it will just display the output. So just run python object detection dash YOLO-NAS dot py. Okay, so let's see whether we are able. Okay, so now I've not set the current directory. Write cd and just copy path and copy the absolute path and just write over here object detection YOLO-NAS dot py and see whether we are able to do object detection on this image or not. So this might take few seconds. So after doing object detection on the images, we will do object detection on videos and then we will implement object tracking as well. So this will take a few more minutes as well. So now here you can see that we are able to do object detection on the image. We have detected that there are two persons. Person, you can see the label over here. Okay. So now you can see the person label over here as well. So we have detected that. Okay, let me just zoom in. I think it is not zooming, but you can see over here we have detected that there is a person, two person out there. So that's fine. The results look good. Let me test on some other image and just write over here image 3.jpg. Okay, so let me do object detection on this image 3 over here. Okay, so it's a PNG image. That's my mistake. Okay, let me just pause this from here and just because it will give an error. So let us do a object detection on this image and let's see what results do we get from here. So now you can see over here, we are able to detect a person, bus, handbag, backpack, person, skateboard, backpack over here, handbag over here. And you can see over here, we have detected that this is a person and we have a confidence score of 0.95. So this means that the model is 95% sure that this is the person. And here we can see the confidence score is 0.93, which means the model is 93% sure that this is the person. And you can see over here, we have with handbag, we have a confidence score of 0.29. It means the model is 29% sure that this is the handbag. And with this backpack, you can see over here, we have the confidence score 0.35. This means the model is 35% sure that this is the backpack. Okay, so now we have done object detection on images. In the next part, we will see how we can do object detection on videos. So let's move on towards the next part. In the last part, we have seen that how we can do object detection on images using YOLO-NAS. So now we will see how we can do object detection on videos using YOLO-NAS. So first of all, what I will do over here is I will just create a new directory by the name. It will be um, lecture number 6. Okay, so it will be lecture number 6. Okay, object detection YOLO-NAS. Okay, so now you can see over here I have created a directory by the name object detection YOLO-NAS. Let me just rename it, like, just to be on the safe end, video. So now we will be doing object detection on videos using YOLO-NAS. So I will just create a new file over here, object detection dash video.py. Okay. So what I will do next is that, first of all, we will import all the required libraries. So to read the video, we will use OpenCV Python library, or to capture or read the video, we will use OpenCV Python library. To do object detection using YOLO-NAS, we will use super gradient. So I will write from super dash gradients dot training import models. Okay, that's good. Next, what we require torch. So I will write import torch from here over here. And next library which we require is numpy library we require, and the other is import math. So I have just imported all the required libraries. As we go ahead, we will be using these libraries, so you can have a better idea why we are using these libraries in the next part as we goes on further. So now, first of all, we will read a video by writing cap is equal to cv2 dot video capture. So currently I'm in this folder, lecture series. I will just go outside this folder and go into the video folder and just read it. So just go into the video folder and just read bikes dot. So I'm just reading this video. Okay, bikes.mp4. Next thing which we will do over here is I will write device. So currently I'm just using my CPU for the object detection. I don't have GPU. So if you have GPU, you can definitely use it. So I will write torch dot device CUDA 0 if torch dot CUDA is available. So it will be torch.CUDA dot is available. So then we will be using GPU, else torch.device, then we will be using CPU. So if we have a GPU available, we will use GPU, else we will use simple CPU. Then what I will write is model is equal to models dot get. So for the object detection, I will be using YOLO-NAS small model. I will write YOLO-NAS. Okay, YOLO-NAS small. So for the object detection, I will be using YOLO-NAS small model, and the pre-trained weights will be grateful. So that's good. And here I will write dot to device. Then what I will do is I will initialize the count over here, like the frame count over here. And then I will write while throw. Okay. Then I will do that red comma frame is equal to cap dot read. And if we have if red, so you can initialize the count over here as well. Count plus is equal to 1. So we will doing the frame count. Over here, we are just doing the frame count. So count plus is equal to 1 is basically we are doing the frame count. And then we will write result is equal to list model dot predict and here I will write frame, and the confidence score will be 0.35, and here I will just write here, and then I will do so now from this result I will just get the bounding box coordinates and the confidence score and the label. So I will just write bounding box dash xy is the result dot predict b boxes. Okay, oh, what is this? So I will just write b box dash xy is equal to result dot predict result dot prediction b boxes dash xy dot to list. Okay, and so this will give us the bounding box coordinates, and to get the confidence score now, I will write confidences is equal to result dot prediction, and I will just write dot confidence to get the confidence value, and to get the labels I will just write labels is equal to result dot prediction dot label dot to list. So this will give us the labels, like this is a car, truck, bicycle, or whatever the object is, and the confidence value, like how much the model sure, like this is the car, this is the bus, and so. And now what I will write for b box dash xy confidence and CLS in. So I'm just looping over all these bounding box coordinates, confidence value, and label. So I'm just looping over the enumerate all these and write b box confidence this labels. So I'm just looping over this and just write now b box is equal to np dot array. So just converting the output over here is as this as output out into array. So I'm just converting a list into array over here, and here I will write x1 y1 x2 y2 is equal to b box 0 b box 1 b box 2 b box 3. Okay, so we have so now this represents the coordinates value of the bounding box. So let me just show you how this is. So what are the x1 y1 coordinates, and what are the x2 y2 coordinates? So now you can see that that for we have a bounding box around each of the detected object. Okay, so these represents the x1 y1 coordinates. So these are the x1 y1 coordinates, and these are the x2 y2 coordinates. Okay, so these are the x1 y1 coordinates, and these are the x2 y2 coordinates. Okay, so now we have the bounding box coordinates over here. So these bounding box coordinates values are in the form of, basically you can say that float. We need to convert these values into integer. So let me just show you these values. So I will just write print x1 y1, and to just write over here name, number, and write count over here, and just add some space. And let me just print this x2, y2. Okay. So let's see what results do we get over here. And now look fine. So let me just run this. So we are in this folder now, currently copy path, copy the absolute path, and just write cd, just write Python object detection dash video.py. So let's run this and just see this bounding box coordinates for each frame. We are not showing the output currently. I'm just checking the bounding box coordinates in each of the frame. Do you mean there's no attribute label? So let me just check this error. Okay, so this is basically dot label. I hope it will work now. This was label, not label. Let's see if we are able to get it takes at most 2 arguments, 3 were given. Okay, so and let me just correct this. Here we will write zip. Okay, so just run this now. I hope this will work now, but if there is any error, we will fix it out. So it's running currently, but let's see. So now you can just see, let me just pause the video. So if you I just scroll it up. So now you can see over here, for each of the detected object, we are just getting the bounding box coordinates, but you can see that these values are in the form of float. Like these are the x1, y1, x2, y2. So the x1, y1, x2, y2. So we just need to convert these values into integers. Okay, so I will just write over here x1, y1, x2, y2 is equal to int x1, int y1, int x2, int y2. Okay, so now we get the bounding box coordinates, and we have converted this bounding box coordinates values into integers now. But next, what we will do is we will just convert our what we will do. We will just convert our integers, basically values into. We will just convert our class values. Like in here, we will just get the output of CLS in the form of 0, 1, like whether it belongs to the 0 class, 0 is the person class, or 1 is whether it is a car. So I will just convert into integer class int is equal to int CLS. Okay. So just converting this into integers. And now I will just compute the confidence value. So I will write confidence is equal to math.c. Okay, so now here I'm just using this math library over here. Right, confidence multiply by 100 divided by 100. Okay, so here we are just getting the confidence value over here. And our label will be f class int or and the confidence. So let me just convert this into class name. It will be better. Okay, so just convert into class name and just add this over here as well. So in the label, we will be getting the class name and the confidence value. And then I will write. So just compute the text size of my label and the confidence value. I will just write d dash size cv2 dot get text size, get text size label font scale. Font scale is equal to 1, thickness is equal to 2. Okay, so we are just calculating the text size over here. And here I will write C2 is equal to x1 plus t dash size 0 plus comma y1 minus t dash size 1 minus 3. Okay. And here we will just write cv2 dot okay rectangle. So first of all, we will draw bounding box coordinates around them. So let me just draw first of all bounding box coordinate. So we write cv2 rectangle frame x1 y1 and x2 y2, and the color of the bounding box will be pink, and the thickness of the bounding box will be 3. So let me just first draw bounding boxes around each of the detected object. Only draw bounding boxes around each of the detected object. So right over here, if cv2 dot arrow dot weight key if cv2 dot weight key 1 and 0x equal to order 1. So if I just press the weight key 1 key, the process will break, and then I will write. Okay, so let me just copy all this. Okay, that's look fine now. Okay, and then I will write else break, and here I will also write cv2 dot im show frame. So that's all good, and here I can write cv2 dot destroy all windows. So let us run object detection on the images and see what results. So sorry, basically we are running object detection on the video using YOLO-NAS. Okay, object detection dash video.py. So you'll see whether we are able to draw a bounding box around the detected object or not. So let's see. It's executing now, so this might take some time. Okay, so here is the error. Unspotted operator for NTO pin. Let me see what's the error over here. Here it is indicating the error. So here I making mistake. So here it should be 0. And then run it now. And let's see whether we are able to do object detection on video or not. So for object detection, I'm using YOLO-NAS. So currently we are just creating a bounding box around the detected object. And let's see how it goes. So now you can see over here, we have created a bounding box around the detected object, but we can't see the label and the confidence score. So let me just press 1. So the operation will break. So next what we'll do over here is just add the label and the confidence score. So to add the label and the confidence score, just write cv2.rectangle and just write frame and just write over here x1, y1, c2, and the color will be the same pink color, and the rectangle will be completely filled, and cv2 dot line dash double A. And here I will write cv2 dot put text, and I will write over here frame label x1 comma y1 minus 2 0 1, thickness will be 1, and the line type will be cv2 dot line dash double A. Okay, let me just run this and see what output do we get. I have not defined the text color, so I can define this as well, but okay. Okay, so you can see that the color argument is missing, and here we have the error. I have not added the color argument, and let me run it again. And let's see whether we are able to do object detection on video with label and confidence score or not. So now you can see that we don't have the class name. Okay, so to add the class name over here, I will just add the Coco class names because we are taking the pre-trained weights of the Coco. So the Coco dataset consists of 80 different classes. So I will just add the class names over here. So these are the Coco class names which I have added over here. And now what I will write over here is class dash name is equal to what it is written, class names, and here I will write class name. Okay, so now you can see over here, if the class name value is 0, this means this represents the person, and if the class name value is 1, it means it represents the bicycle, and if it is 2 over here, if the class name comes 2, then it will be car. Okay, so that's fine. Just copy this from here and add this over here, and let's run this. And let's see whether we are able to do object detection on the video, and whether we are able to get the confidence and the labels value or not. So let's see. After we are able to do object detection on the video, next. So now you can see that we are able to do object detection on the video, bicycle, person, and you can see over here, we have the confidence score over here as well. We have detected the traffic light over here as well. Okay, so that's impressive. So you can see over here, we have detected the traffic light, we have detected the bicycle, we have detected the person. Okay, and all this is working fine. Okay, and we have also detected the handbag over here. Okay, so let me just test on some other video and see what results do we get. Just write over here then a demo. Okay, now let's see whether we are able to do object detection on this demo video or not. And let's see how does it goes. Okay, so now you can see that the frame is not able to fit in the screen. What we will use cv2.resize function. So I've just copied, I will just go over here and just copy the resize function. Just copy this out from here and just paste this over here. So just go over here and just paste this over here. Okay, and out. So we will save the output video over here as well. So I will just copy this and add this over here. Here. So that's perfect. And just I will write out.release cap.release. Okay. So everything looks fine, and just write over here. Okay, so now let's run this and see whether we are able to do object detection on this video or not. If it is working fine, object detection is working fine, then we will go towards the object tracking. We will integrate deep sort object tracking. So for object tracking, we will use sort algorithm. Okay, so I know there is an error. Okay, let's write frame dash width is equal to int cap dot get 3, and the frame height will be frame height is equal to int cap dot get 4. Okay, so now let's run this again. Okay, and let's see. We will also see whether we are able to save the output video or not. So now you can see that the video is fitting in the screen, and here you can see the bounding box around it as well. Here we have the label person, although it's very small, but we can read it person, and here we have the confidence score, and these are the frame coordinates value of the bounding box in each of the frame. Okay, so these are the bounding box coordinates in each of the frame. Okay, so the results look fine, and the results are very good as well. So you can see the bounding box around the object. Here we have the label person. So that's fine. So now you can see that how we can do object detection on the video. You can test it on other videos over here as well. You can, if you just want, like we just run some other video 1. And let me just scale it around 50%, 50%. So now let's run this. Okay, so now we are doing object detection on this video. Let's see how does it go. So now you can see over here, we are able to detect the car. We have the label car over here as well. You can see over here, we have the label car. We have the confidence score over here, like 44%, 71%, like the model is 71% sure that this is a car. Okay, so that's fine. So let's close it. Okay, so just press 1. Okay, so let's see if we are able to save the output video or not. Okay, and it will be okay. And let's see, this is the output. So you can see that we are able to save the output video, and here is our output video. You can see that we are able to detect the objects. Like you can see that it's working fine, and you can see over here. Okay, the results look fine. No such issues in the results. Okay, and we are able to save the output video as well. So that's good. So now in this next video, we'll see how we can do object tracking, or how we can integrate object tracking as well. So let's move on to the next part. The last part, we have seen that how we can do object detection using YOLO-NAS. In this part, we will see how we can track the detected objects using sort algorithm. So we will do object tracking. So we will track the detected object using sort algorithm. And for object detection, we will use YOLO-NAS. And for object tracking, I will use sort algorithm. So let's see. So first of all, I will just go to over here and write sort GitHub. And I will just click on this first link. So to implement object tracking using sort algorithm, we will be using this GitHub repo. What basically we do in object tracking is that we basically assign a unique ID to each of the detected object. So when the object enters the frame, that object is being assigned a unique ID. Until the object remains in the video or in the scene, that ID remains with the detected object. And when the object leaves the scene, that ID is removed. So in object tracking, we assign a unique ID to each of the detected object, and until the object remains in the scene or in the video, that object is being assigned that ID. And when the object leaves the scene or object disappears from the video, that ID is removed. Okay. So this is all. Or if you are doing object tracking in the live webcam feed, so each object is being assigned a unique ID in each detected object is being assigned a unique ID in object tracking. And until the object remains in the scene of the webcam, that ID remains with that detected object. And when the object disappears, that ID is removed. So in short, in object tracking, we basically assign a unique ID to each of the detected object. And for object tracking here, we will use sort algorithm. So this is the GitHub repo of sort algorithm. Thanks to Ably for this repo. And you can just click on here, just open this sort.py file. So this sort.py file contains all the algorithm of the sort. So we will just copy this code from here. So you can see that I've just copied this code from here and just go into there and just go over here and just create a new file by the name sort.py. And inside that file, just paste all this code which you have copied. So just pasting this code and just clicking on Control S. Okay, so just so now you can see over here we have created a file by the name sort.py file. So now for object tracking, we will be using sort algorithm, and for the object track detection, we are using YOLO-NAS. So for each of the detected object, we will assign a unique ID using sort algorithm. That is what object tracking is. In object tracking, we assign a unique ID to each of the detected object. So just close all these files. So first of all, I will just click over here and create a new directory. Lecture number 7, object tracking and YOLO-NAS. Okay, so that's fine. And inside this directory, I will create a new file by the name object tracking.py. That's fine. So next, what I can do is I will just copy the code. So here you can see that we have written the complete code, how we can do object detection on video. So I will just copy this code from here and just paste all this code over here. Okay, so I have added the code of object detection on video. So now here I will integrate the object tracking. So for object tracking, I'm using sort algorithm. So first of all, what I will do is I will just import all the functions which I have in this sort.py file. So I will import all the functions into this our object tracking.py file, all the functions which we have in the sort.py file. So I will write over here from sort import. So I'm just importing all the functions which I have in the sort.py file. Next, what I will do is I will initialize the tracker. So I will initialize the sort tracker over here. So what I will do is I will initialize the tracker over here. So I will write over here is tracker is equal to sort. And here I will just define some parameters, maximum age. Okay. So if I just go over here so here you can see that we have a class by the name sort. If I just go above. Okay, so now here you can see that we have a class by the name sort. And inside that class, we have maximum age, minimum hits, and IRB threshold as parameters. So we initialize all these 3 parameters over here. Okay, so I will write over here. So if you just see over here, this is short. So S is capital while other is short. So I've just written mistakenly wrong. Okay. So I've defined maximum age as equal to 20. And I will define minimum hits as 3. And also I will define the IOU threshold as 0.3. Okay. So I've defined the maximum age as 20, minimum hits as 3, and IOU threshold as 0.3. So what does it mean by maximum age? Why we have defined it 20? So for example, if you ID number 1 or if some ID is lost, for example, if the ID number 1 is lost, how many frames we should wait to get it back? Okay, so if the ID number 1 is lost, how many frames we should wait to get it back? So if I have defined the value 20, so it means that if any ID is lost, we will wait 20 frames to get it back. So the higher the number of the higher the value of maximum age, the longer it will wait to get the ID back. So again, if the maximum age, what value defined is that how many frames, like here our algorithm or model will wait 20 frames to get the ID back. So if any ID is lost, how many frames our model sort algorithm should wait to get it back? So it will wait 20 frames to get that ID back. So the higher the value, the longer it will wait for the ID to get it back instead of assigning a new ID. So it will wait for, if any ID is lost, it will wait 20 frames to get that ID back instead of assigning it a new ID. So now I have initialized that sort tracker. So for tracking, I'm using sort algorithm. So what next I will do is, so just comment this out over here. So we will not use this. So just comment out all this. Okay. So what I will do is, we will just start from a bit back now. What I will do over here is just move it a bit back. Now I will just press enter over here, and I will write current array is equal to np dot array. We have sliced the numpy, and I will write over here x1, y1. So these are all my coordinates of the bounding box, x2, y2, comma confidence. So I will add these 5 values into the array, and then I will write sections is equal to np.v stack. So in the case of list, we do the append operations, but in case of array, we do the vertical stack, like one after the other. So I'm doing just vertical stack over here. And here I write detections, comma, current array. So I've not initialized the detection, so I will just initialize it above over here. So here I will just initialize the detections. I will write detections is equal to np.empty 0, 5, because we have these files values over here 1, 2, 3, 4, 5. So we have done till now. Next, what we will do over here is I will just go down a bit, and I will write over here is tracker dash detections is equal to tracker dot update detections. Okay. And what I will do next over here is so if you just keep this out of the for loop, that will be great. So just keeping this out of the for loop. And next I will write over here If length tracker direction is greater than 0, then what I will do, b box xy is equal to tracker directions for, and then further I will write identities is equal to tracker directions, and then here I will write a, and further what I will write over here, categories. I think these terms might be new for you, but as we go ahead, you will get understanding what are these terms. Tracker directions. Okay, so here we are just getting the bounding box coordinates over here. So these are the bounding box coordinates values which we are getting over here. Like you can see that, like it means we are taking the first 4 rows. So if you just key over here, the first 4 rows contains the bounding box coordinates x1, y1, x2, y2. And here we are just taking the unit. So basically, here you can see that we are just integrating the tracker. We have initialized a tracker over here by the name tracker. So we are just initializing the tracker over here. And here we are just calling the update function of the tracker. So here you can see that here we are just assigning each of the detected object a unique ID. And the categories, we have the name, like we have detected car, we have detected truck, we have detected bicycle or some other object. So plus further, I will just create another function over here. So here I will just create a function by the name draw dash boxes. So I will write define draw dash boxes. And inside this function, what parameters which I will initialize over here is the current frame, the bounding box coordinates, the identities, like a unique ID to each of the detected object, the categories, the labels, and the next which we will initialize over here is names, and further along with we'll also initialize the offset value. Offset is equal to 0. So further we'll go, and now I will do is over I comma box in enumerate the box, and I will write over here x1 plus is equal to offset 0 comma x2 plus is equal to offset 0 comma y1 plus is equal to offset 0 comma y2 plus is equal to offset 0. You can remove this term. We don't need this actually. I think this will be wrong a bit. So that's fine now. Okay, so there is a mistake. I have not said x1, y1, x2, y2 is equal to int I for I in box. Okay, so that's fine. What next I will do over here? I will just write cat is equal to int categories I if categories is not none, else 0. So that's fine. So just we will copy this and we will do the same thing for identities as well. So I will write for the identities, I will just copy this name and here write in, or just write ID because this will mismatch. And then I will write over here label. In the label, I just want to show the unique ID. So in object tracking, basically assign a unique ID to each of the detected object. So in the label, I just want to show that unique ID with the label name, like class name. You can say that whether it's a car, bicycle, with a unique ID. So I will just write ID, just a string ID plus and here I will just pick this names from here, class names, and here I will write categories. Okay, just correct this from here. It should be like this. Okay, and then I will just go further. And here we will write W, H, is equal to CV2 dot get text size label CV2 dot font dash Hershey dash simplex. And I will further write 0.6, 1. So that will be fine as well. And I will write CV2 dot rectangle. And here I will write image x1, y1, x2, y2. So I'm just creating a bounding box around the detected object, and I will write over here 255, and here I will write 2. So this is the thickness of the bounding box which I have written over here. And then I will press enter. And I will write CV2 dot rectangle. And here I will write image x1, y1 minus 20, x1 plus w. So this is the rectangle which we are creating above the bounding box where we will put the label and you can say that a unique ID of the object. Y1, and further we will write over here. So this is the color of the rectangle. So here I have just defined a blue color or light blue, and here I will just define some other color. So it can be, let's like this. Well, I don't know what this color is, but let's see what this color is. And we just want this rectangle to be filled, not empty. And I will write CV2 dot put text. And here I will write image label x1, y1 minus 5. CV2 dot font dash Hershey dash simplex 0.6. So this is the font text size which I am or this is the like the font which I want to just display into the rectangle above the bounding box. Like in the label, I will display the ID and the confidence score. And the color of the text will be white. And it will be scaled 1. So that's all from here. Hope it will be fine. There will be no errors. And let's return the image. So I will just go down now and I will just try it over here. Draw dash boxes, and inside this I will write frame. Then just copy this and paste this over here, and copy identities and paste this over here. Copy categories and paste it over here as well. So I have done all this, and let's run and see if there is any error so we can fix it out. Okay, so just copy and the path, copy the absolute path and write cd and just run python object dash tracking .py. Let's see how does it goes, and if there is any error, we will try to fix it up. Let's see. Just waiting for it. There is a 50-50 chance, like it might goes very good. There might be an error. So let's see how does it goes. So this might take few more minutes, and let's see how does it goes. No module name sort. Currently I am in this directory. Okay, so just move sort into this folder. Now run this. So it's running. Let's see what is error. Right. Okay, that's wrong. That was also correct, but I have not moved sort into this folder. So let's run this. I hope it will work fine now. If there is an error, we will fix it up. And let's see if we are able to implement object tracking using sort, and object detection using YOLO-NAS. So here we are integrating object tracking into the object detection algorithm. Detection np.mt05. So where it is, and let me see what the error is over here. Oh, my mistake. It should be like this. So this error is fixed. Let's see if there is some new error appears or it goes fine. Okay, I know this video is getting very long, but let's see how does it goes. If there is an error, we will try to fix it up. That one. np.p stack, but 2 were given line number 69, and here what we have facing the error. Okay, so I think there should be double brackets. the same issue. So let's run it now. And let's choose. And let's see what results do we get. Okay, index 8 is out of range. So to fix this error, I have just made few changes in this sort.py file. So I will add this sort.py file in the GitHub, and I will add the link in the description so you can just download this updated sort.py file. So you can just just check the description and just uh, click on the GitHub link. There you will find the updated sort.py file. Just download this sort.py file and place it into this folder. Okay. So don't use the previous sort.py file which I've copied the code from the GitHub repo. So don't use that sort.py file code. Use this updated sort.py file which I will place in the GitHub, and you can just download it from there. So now what I will do over here is other uh, other change which I made into the code. Let me just explain you. Well, the other thing which I will change, which I'll made over here is I will just add CLS over here, the class name you can see over here. And so CLS represents the class ID. And what I will do over here is I will just update it to 06, because now you can see over here our array consists of 6 elements, 1, 2, 3, 4, 5, 6. So I will just update it to 06. So it will be create 06 over here as well, 0 to 6. And here we will also have 6 elements in the array now, 1, 2, 3, 4, 5, 6. So you just need to make these two changes, which I have just told you now, and just run this object tracking.py file and see what results do we get. So now we are just implementing object tracking using sort algorithm, and we are integrating with it with object detection using YOLO-NAS. So now you can see over here. Uh, Let me just make it to a bigger so you can we can clearly see it. Okay, so just 0.8, 0.8, and just run it. So now the reason for making it a bit bigger, so we can see a unique ID and each and every detail. So this will be better and clear now. Okay. Okay, so let's see how does it goes. So now you can see over here, each of the detected object is being assigned a unique ID. Like this car is being assigned a unique ID 5. This will be assigned a unique ID 4. This is assigned a unique ID 7. This is assigned a unique ID 17. So now you can see that each detected object is being assigned a unique ID. So using object tracking, we assign a unique ID to each of the detected object. And to implement object tracking, we are using sort algorithm, and using object tracking, we are assigning a unique ID to each of the detected object like 7, 11, 18, 17, 9, 15, 14, 6, 4, 5, 2, 8. So using object tracking, at each of the detected object is being assigned a unique ID, and we are implementing object tracking using sort algorithm. Okay, so you can see over here, each detected object is being assigned a unique ID, 18, 17, 11, 7. Okay, so let's test on some other video. Just write other video name bikes.mp. And let's see how does it works on this video. So if I just, so now you can see over here, let me just make it, let me just remove the resize frame from here because we don't need it. Frame. Let's see how does it looks like. And let's see how our results look like. So this might take few more seconds and see how does it works. Okay, so this might take few more seconds and I'm also waiting to see the results. And let's see how does it go. So let's see. So now here, just open this. So now you can see over here, each of the detected object like person, bicycle, backpack, these traffic lights. Look, so you can see that each of the object is being assigned a unique ID. And that ID will remain with that object until this object is in the video. Okay, so for example, if this person, until this person is in this video, this ID will remain with that person. And when this object leaves the scene or disappears from this video, that ID will be removed. Okay, so now you can see that each of the object is being assigned a unique ID. So that's good. Like you can see over here. So that's working perfectly fine and impressive results. Like we can see over here, we have assigned a unique ID to each of the detected object, like bicycle 57. So, but this is what do we do in object tracking? In object tracking, we basically assign a unique ID to each of the detected object, and that ID remains with that object until that object is in the scene. And when the object uh, disappears from the scene, that ID is removed. Okay, so these are the results. So in this video tutorial, we have seen that how we can integrate object tracking using SORT algorithm with YOLO-NAS object detection. So this is all from this part of the video. So far, we have seen that how we can do object detection and object tracking using YOLO-NAS. So now we will do a project and we will see how we can do vehicles counting. We will count the vehicles entering and vehicles leaving. So here is a demo video. So let me just show you. So if I just go to the videos, so if you just see over here, so what we want to do is we will basically, so now you can see over here, basically these are the vehicles leaving. Okay, and these are the vehicles entering. Okay, so what we want to do, we want to count the vehicles entering, which is in the north direction, and the vehicles leaving, which is in the south direction. So we want to count the vehicles entering. So the vehicles entering mean the vehicles going in the north direction, and the vehicles leaving means the vehicles going into this south direction. Okay, so we will write a program. So what our main goal is that we want to count the vehicles entering and vehicles leaving. So for this, we will use object tracking SORT algorithm, and for object detection, we will use YOLO-NAS. So let's move towards the code part. So first of all, I will click over here and just click code directory. I will write project, and the name of the project is vehicles counting entering, vehicles counting entering leaving. Okay, so this is the name of our project. Okay. So here you can see that I have created a directory by the name project vehicles counting entering and leaving. So we will count the vehicles entering and leaving. So I will just create a file into it, and vehicles count entering leaving .py. Okay, so you can see over here I've just created a file by the name vehicles count entering and leaving.py. So I will just close this up and just go to open the browser, and let me just write over here for GitHub. Okay, I will just go towards this GitHub repository of SORT over here and just click on the sort.py file, and just copy this code from here. Okay, and then I will just go back to, let me just close this up. I will just go back towards the PyCharm over here and just create a new file by the name sort.py. Okay, and inside this, I will just paste this code of sort. Okay, and just control S. Okay, so in the last project, I've implemented object tracking using YOLO-NAS. So I will just open this and copy all this code from here and just paste all this code over here. Okay, just remove these comments. Okay. So one thing I will do is I will make few changes into this code. So just make this to 5. Okay, and just remove this because we don't need the class name. Okay, and what else we just need to do? One thing you just need to do over here is uh, here you just need to define total count up is equal to 0. In the total count up, we will save the vehicles entering, and in the total countdown, we will save the vehicles leaving. Okay, total countdown is equal to 0. So we have initialized total count up and total countdown. So in the total count up, we will save the vehicles entering, and in the total countdown, we will save the vehicles leaving. We will save basically the count of vehicles leaving. In the total count up, we will save the count of vehicles entering, and in the total countdown, we will save the count of vehicles leaving. Okay, so we don't need the draw dash boxes function over here, so you can just remove this. Okay, and just remove this from here as well. Okay, and you can just remove these things as well. Okay, so first of all, I just need to do two things. I just need to define limit up and limit down over here. So I will do is basically the next thing which I will do over here is I will just open this and just go towards the okay, just towards our folder, which is this over here, and let me just open the video. I just want to save an image from this video. Okay, so just click over here and save a photo from a video. So I'm just saving a photo from the video over here. Okay, and I'm just saving a photo from here. Okay, YOLO-NAS course, and here I will write where we are, basically object tracking, and over here I will just write in the window, in the images, I will just save this image, vehicles entering, image entry and leaving. Okay, so just close this up from here, just close this video and just go towards the image folder over here and just open this in Paint. Okay, so just opening this image in the Paint. So what I will do over here is just shrinking up. So first of all, just create a line over here and other line you should create over here. Okay, so when our center coordinates passes by this line, okay, when our, for example, bounding box, for example, you can say that when our bounding box, so we can see that whenever we detect an object, we create a bounding box. Okay, so in the bounding box, we will have a center coordinate. So whenever this center coordinate passes by this line, then we will do the count up and the count down. Okay, this line is a bit not very good. Okay, so this was not a straight line, so I'm just correcting it. Okay, and let me just modify this. Okay, so just modifying it a bit. Okay, so now it looks good. So we just want to find the coordinates of these lines. So let me just find those coordinates. Now look fine for it. So here we have the coordinate, like just focus over here. Okay. So if we just write over here 233, 853, or you can see that 225, 860, no, 225, 850, that would be fine. So here I will write limit down is equal to, it will be 225, 850, 225, 850 over here. And the other point will be over here, which will be 963, 850, 963, 850. So this will be the limit down, and other we will have the limit up. Limit up is equal to, okay, so if I just click on here, we have 979, and here we have 1667. 979 and 1667, 850. Okay, so now you can see that we have just found out, created two lines, and here are the coordinates of those lines. Okay, and we have created two empty. Okay, so that is not correct. There will be empty list. Okay, so that's fine as well. Ready to go on. Okay, and anything further we just need to do. Okay, so here we just need to add few things. So if I just update to a result tracker so that it will be easy for me to remember. Results tracker, and I will write for result in results tracker. That is fine. I will write x1, y1, x2, y2 is equal to result over here, and click on enter. Then I will write x1, y1, x2, y2 is equal to int x1, int y1, int x2, int y2. Okay, so here these are the bounding box coordinates over here. And here basically object tracking, we assign a unique ID to each of the detected objects. So I have the ID over here as well. So we basically need to find the center coordinate of the bounding box. So basically right over here, Cx is equal to, or you can just write Cy is equal to int x1 plus x2 divided by 2 int y1 plus y2 divided by 2. So we are just finding the center coordinate of the bounding box over here. And to display this center coordinate, I will write cv2.circle frame is equal to cx comma cy, and the color of the circle will be, radius will be 5, and the color of the circle will be, okay, so just add pinkish color up to the circle, and the circle should be filled. And then click on enter. Now I will create, now what I will do, I will create rectangle, I will create basically, we will create bounding box around the detected object. So for this, I will use cv2.rectangle frame x1, y1, x2, y2, and it will be 85, 45, 255 over here. and dot comma, and I will write the thickness of the bounding box will be 3. So I have created bounding boxes around the detected object using cv2.rectangle function. Then I will write label is equal to, over here I will just, in the label I will just want ID and nothing else, okay? So I will write int ID. Okay, so in the label we will have a unique ID which we will assign to each of the detected object. And you can just copy, if you just go to over here, in last lecture, which is our, okay, so the last lecture, okay. So just copy this text size function from here. I will have written over here. Okay, so you can see over here, we have written this text size function. So just copy this text size function, all these things from here. So just copy this because we need the same things over here. Okay, so just add these things over here. Okay, and just adding up these things. That's good. And we don't need this currently. So that's fine. Let's see if it is working fine. So then we will do the count. Let's first see if it is working fine till here. So first we'll focus on this. So I will just write cd and let me just set this project as my current directory, copy path, and I will write Python vehicles count entering living .py. Okay, let's see how does it goes. If there is any error, we will definitely fix it out. So this might take few minutes to execute, and let's see how does it works. So now you can see over here. Okay, so looks all good from here. Nothing mistake, but let me just test it out on the video which I want. So the video will be over here, vehicles counting. Vehicles entering and leaving. Vehicles entering and leaving. So this is the video which I want to test, and then run this out. And let's see how does it goes. So this might take few minutes further, and then we will have the results. Okay, I think let me just resize the frame. So just add this, just make it 0.6 over here, 0.6, and right over here, resize frame. Okay, now let's run it again and see whether it fixed our screen or not. So now you can see that a unique ID is being assigned to each of the detected object. Plus you can see over here, we have this center coordinate over here. You can see the center coordinate over here, and we have assigned a unique ID to each of the detected object. So the results look good up till now. And the results look fine. There is no issue in the results. Okay. Okay, and so prediction results are fine, look cool. So there is no issue in the detection results for now. Like we have directed the object, and this is a unique ID we have assigned to each of the object. Okay. So just making few things clear. These two are missing. Okay, so okay, that's fine. So what we will do next over here is we will do the count of vehicles entering. Okay. So now we need to do the count of vehicles entering. So first of all, we will just write limit up over here. So I will write if limit up and write 0 cx limit up to and limit up 1 minus 15 cy limit up and 1 3 plus 15. So basically what we are doing is, let me explain you from here. So now you can see that what, for example, this is a limit up from line. This line represents the limit up and this line represents the limit 2. So basically we are saying that whenever, so we just draw a line. So these are the x1, y1. So x1, y1. So what we are saying that if the center point lies between this line, like we are just saying that if the center point lies between this line, then we will do the count. Okay, so we are just saying that minus 15 plus 15 means if the center points lies between this line, then we'll do the count. Okay, so just making sure for this. Next thing I will do is if total count up dot count id is equal to 0. Okay, so if the id has not crossed already, okay, if that id is new, total count dot append height. So this will be total count up. Okay, and so that's fine. And what I will do for here is limit. Why there is an issue? Limit. Okay, this is not clear. And so this is for the limit up, and then now we will do for the limit down as well. We need to add few things, so just copy all this from here and just paste it out over here and just make it to limit down. Okay, so just make it to limit down and limit down, limit down, limit down, limit down. And here I will write total countdown, total countdown, total countdown. So that's fine as well. Okay. And here I will just create two lines. CV2.line frame, comma, limit up 0. Limit up 0. Limit up 1. Limit up 2. Limit up 3. Okay, and next thing which we can do over here is the color of this line will be 0, 0, This color of this line will be EGR, it will be blue. Okay. Okay. And the thickness of this line will be 5. Then I will just create another line over here. Just copy this from here and just paste this and just write a limit down over here, limit down, limit down, limit down. And here I will just write, okay, so the color of this line will be blue again as well. So, okay, so we have created 2 lines. So just copy this from here and just go down over here. And here you can see that whenever the car passes this line, the color will change to green. And whenever this passes through this, so the color will be changing to blue green. Okay, so that will be fine again as well. Okay. What next we can do over here is we want to display the count. So for this, I will do over here. I will write cv2 dot put text frame str length, and here I will display total count up first. Then I will also display total count down. I will just write other line for this. And here I will just define the coordinates. So I just want to display the total count up over here. So you just want to display total count up over here. So this location will be 131743. Just focus over here, please. So this location will be 131747. Okay, so the location will be 131747. And I will write cv2 dot font dash Hershey dash plain, comma 5, and the color of the text will be this should be white. Okay, so the color of the text will be white. And other thing which I can do over here is 5 again. So now we will also display the total countdown. I will just write enter and just change the coordinates. So just want to display the total countdown text over here. So this will be 141.91. So I will just add 141.91 over here. Okay, and here we will have total countdown. Okay, so just copy this from here. Okay, so that's look fine. Let's just run it. Before I run it, let me just make it to 0. We will test it frame by frame. And let me just use YOLO-NAS large model. Okay, that's fine. And everything else same. So let's run it and see how our results look like. Whether we are able to do vehicles count or vehicles entering and leaving or not. So I have executed it. So this might take a few minutes to start, and then we will see the results of the count. Let's see. So it has started. So these are the count of vehicles entering. Here you can see. And here we have the count of vehicles. So I will just, as I set the wait key, 0. So I will just press space key. So then it will move frame by frame. Okay, so I think this will not work as I'm using a larger model. So let me just fix it out. Okay, so okay, just cv2.wait key 1 and just stop this. And let's use YOLO-NAS small model because I am just using CPU and there might be issues. Okay, so let's see. Because I'm just using the CPU and the processing will be very much slow. But if you have GPU, then you can use YOLO-NAS large model. But I will for now stick with YOLO-NAS small. So now let's see how does it goes. Okay, so here you can see. So now you can see over here. Okay, so here you can see that we have the vehicles leaving count and here we have the vehicles entering count. Okay, so now you can see over here, as this center point intersect with this line, we will have the increase in the count. But if you just see, so now you can see, okay, that's fine. Okay, that's good. So the results look cool. So the simple methodology, as this center point, you can see this center point intersect with this line, then we have the count. Okay. So it's a simple methodology over here. As we're using YOLO-NAS small model, so some object detections are missing, but these can be fixed. Okay. Let me just see. Okay. 18, 19, 21. Okay. The count is good. Now you can see 2 cars are coming. Okay. So let's see. It should be 22. This should be 23, 24, 25, 26. Okay. 23, 24, 25, 26. Okay, so the count looks awesome. The count is accurate. This should be 27. And when this crosses, this should be 28. 28. And when this crosses, this should be 29, 30. This should be 31, 32. Okay, that's good. And if this crosses, this should be 34, 35, 36, 34, 35. And this should be 36, 37. Okay. And some object detections are missing because we are using YOLO-NAS small model. But if you use YOLO-NAS large, the detection results will definitely get better. Okay. So that count is same, but we just need to make this UI a bit better. So we can work on it to make this UI much better. I have modified the UI a bit. I have just, these are the previous cv2.putText function. These are to the previous cv2.putText function. So I've just added a rectangle and inside this rectangle, I've just put this text. So vehicles entering and vehicles leaving. So I have just modified the UI a bit, which you can see over here. So let me show you the updated UI. Else everything is same. I don't have changed anything. Just I modified the UI so that it looks better. So let me show you the final output and then we will close this. So here is the output video. You can see that UI looks much better now over here now. So now you can see over here. Here we have the vehicles leaving count and here we have the vehicles entering count. So as this center point intersect with this line, we have the vehicles leaving. I'm not explaining this because there are so much vehicles which are entering, so it is difficult to count. But you can see over here, we are able to do the vehicles count over here. And the results look very impressive in short. Okay, so let's see over here. So the vehicles count works fine and we are able to get good results. and overall the UI is looks much better now, and we have got good results as well. Okay, so now you can see that in this project we have implemented vehicles entering and vehicles leaving, and I have tried to explain you truly how you can implement this project on your site from scratch. Okay, and you can see that we are able to do vehicles leaving count over here. Like you can see that as this center point intersect with this line, then we will have the vehicles leaving count. And when this center point intersect with this line, then we will have the vehicles entering count. So that's all from this video tutorial. Please try to implement this project on your site as well. If you have any question, do let me know. See you all in the next video. Till then, bye bye.